The broadcast is now starting. All attendees are in listen-only mode.
Okay, welcome back everybody. Thank you very much for coming today. This is Dr. Mansour, and today is May 31st, is the last day of the month of May. There was a statement here, maybe the webmaster is doing something on my website here. There was a statement, it was here yesterday. I believe he's doing something right now, or he's updating. About June 1st, the NCEES will start opening the registration for the October exam. And as you know, the October exam will be offered October 22nd and 23rd, which is on Thursday and Friday. So so follow up with the NCEES and all these free classes. By the way, the free workshops, we put them here. My people are helping me, or my staff, they are helping me remotely from home, so takes a little bit of time. So be patient, but all the videos that they are free videos, seismic, transportation, construction, surveying, they are available here on our website under this free workshop videos. So this morning I was arranging my stuff, or try to arrange myself and try to organize myself after this break during the fasting of Ramadan. And I came across some old exams, and I found that they are good. So I I have them here in front of me, which is, and I send it to all of you. So today is, I updated also the schedule, because I found that the schedule available on our website is correct, except there is one day I found there is a conflict. As I said, except yesterday, 5:30, I supposed to be here yesterday between 4:30 and 7:30. Please, okay, do your best to attend the sessions. And I will make up. I remember I missed one session here, so I will make up, and after that we'll go to transportation and construction until I will start resuming the classes. 7-11. 7-11 is, I believe, 7-11. 7-11 is, yeah, 7-11. Okay, 7-11. There are 7-11, very important. 7-11, by the way, this date 7-11, or the term 7-11. 7-11 stores and 7-11 in transportation. We have the phases, the sum of the phases 7-11, and also 7-11, chapter 7, table 11. This is in my 7 Breadth AM book. It does have a very important table, which is chapter 7. Chapter 7, table 11. Here is chapter 6, chapter 7, materials. And there is a specific table here. I get by chance came 711, so it's not intentionally designed to be that, but it came to be 711. Let me locate it very quick. And this is a table that it has the properties of soils. So here it is. So you can, here it is, table 711. So on page 476, basically this table has the properties, the soil weight volume relationships, like the void ratio and specific gravity and so on. So this is so I will be following the schedule for the free webinars as outlined here, except I believe the construction, the last day 6/28, I changed it and I send an email to everybody with the new change, because this has a conflict with the seismic class, the one I'm teaching. So I decided to change this only, and this is 6/28. 6/28, I made it 6/28. I made it from 9 to 12. And these three changes, I made a change yesterday. And there is another change on June 13, sorry, and there is a June 28. Those are the three changes I made because I found there is a conflict between these dates and other classes I am teaching, which is also free. The seismic classes I offer at this time to be free to help everybody. So welcome back after the short break that I have or I had. Because of the month of Ramadan, we're fasting and we break our fast last week, and health-wise everything is fine except yesterday I had headache, so this is why I was not able to teach the whole day yesterday. I was teaching surveying yesterday, the surveying class, the regular surveying class for the California, and I felt that the headache, it will not help me to do a good job with you guys, so I moved it from yesterday to today. So thank you very much for coming, and thank for all of you who sent email yesterday or emails yesterday asking me about my headache. The headache is gone, and I will do my best. I will resume. Okay, I know there are many exams, many exams I sent before, and you are expecting some solutions from me. I will work on that or keep working on that and do your best. Okay, so I sent the three exams this morning. Fall 2017 exam and fall 2019 exam number 2 and fall 2019 exam number 1. For some reason I found these exams, and some of these problems, by the way, they are in the mini exams that I sent it to you before. So I send it to everybody to the best of my knowledge. This morning I came here to the office and I scanned them and I sent them to all of you. I hope that all of you got it. If you didn't get it for any reason, email me info@psb.com and I will be glad to send it to you. So I hope that everybody is healthy and everybody is your camera on? My camera is on. Salim is asking, anybody has a problem with the camera? Let me see. Is my camera on? Yes. Is the video on? Yes. Let me click it one more time. Just to make sure the audio and the video are working. I hope that all of you receive both the audio and the video. Any problem with the audio and video, or video, please let me know. If not, Salim, I would recommend you to get out and come back again and join. Everything is okay. Thank you very much. Now it's okay. Thank you very much. I really appreciate that. So as I mentioned that the June 1st will be okay tomorrow. The NCEES will start the registration for the October exam, and this is going to be October 10/22 and 10/23. So because of the cancellation of the April exam, so they are going to split the groups, structure and construction, and the 5 areas. So go to the NCEES. We just announced it. For some reason, I'm not able to find it on our website. It was there, study, unless the webmaster is doing something. I asked him to do something, but probably he is doing something, and probably this statement he's modifying or something like that. This is my guess, but it was here yesterday. So try to do your best and try to stay safe as much as you can, and I will do all my best to help you to prepare for the October exam, and I hope the October exam will be the last exam that you will take. And so today is the Civil AM, the Civil Bread AM free workshop, and I said that I owe you one meeting. I did not able, or I was not able to make it. This is way back. For some reason, I was not able to make it. So I will schedule one and provide you with whatever solutions you need from me. So if we look, let's start with chronological order, and I will select some problems, and I will do my best. I am here from 1 to 4, and after that we will resume. Even I need to go to the materials because this is where we stopped, material section. But let's look to this problem here, which is in front of you. This is a truss problem, and the zero force members, as you know, or zero force member is a common question. I heard that it's a common question, so we need to pay attention to the process or the method or the rules or the cases of the zero force members. And if you look to this truss here, you will find that we have only one load acting at this joint D. The remaining joints and supports, they have no loads. So the zero force members, or a zero force member, is a member that does not have any force or does not carry any force, either tension or compression. And there are 2 rules. I discussed them before. The 2 rules, you don't have to memorize them. 2 rules, or okay. If you have 2 members forming a joint, and these 2 members must be non-collinear members, like member AB and member BC. These 2 members, truss members, they are non-collinear, and these non-collinear members, they have no load and they have no support or anything. So in this case, thank you very much, my friend, for giving the answer. So this is the rule number 1. So rule number 1, when you have 2 members that are forming a joint, and these 2 members are non-collinear, okay? Non-collinear means that they have an angle. They are not having the same bearing or the same line of action. For example, if you look to these 2 members A, B, C, this angle is 180 degrees. So we call them collinear. This is collinear members. Collinear members. So the rules say that if you have 2 members that they are non-collinear and there is no support or load at the joint, so these 2 members will be zero force members. This is the rule number 1, as you recall. And rule number 2, rule number 2, dealing with 3 members. So 3 members like this, okay? AB, BC, and BD. So 3 members, AB and BC and CD, 3 members forming a joint. Okay, they are meeting at a joint here, and 2 of them are collinear. This must be collinear. Okay, and there is no load or support here. There is no load or any support like this or this. So that this member must be 0. Third member must be 0. So these are the 2 real rules that we normally state in structure analysis books. Any structure analysis book you have, you will find these 2 rules. Some books, they say that they are 3. but they came from here. They came from here. So even some books I saw they put it as 4 review books. But these are the 2 rules that if you remember them, you will be able to recognize that. So if you look to this here, so it is AB or BA and BG and BC. These are 3 members. This member and this member and this member. They are forming a joint. Here they make it 90 degrees. Here not necessarily to be 90 degrees. Okay, so in this case, 3 members forming a joint, and there is no any load here, or this is not a support, so this member is 0. So BG is 0. Okay, so BG is 0. That means that either A or B, because right now CG, so this is out and this is out. A process of elimination. I need you to remember that. A process of elimination. A process of elimination is very powerful, and some problems can be solved using the process of elimination method or a process of elimination technique. Since I know that BG is a 0 force member, so in this case, I can eliminate these 2 here. Okay, because BG is not. BG is in, so at least 50-50. If you have only 1 minute left and you are able to recognize that this member is 0, so in this case, by the process of elimination, I can eliminate 2 answers, and after that, there is no any time left for me, few seconds. He will tell you, be ready, put the pencil. So in this case, I will pick one and pray to God that I pick the right one. But at least 50-50 instead of, but I can proceed right now if I have the time. So I can proceed. Since this member is 0 force member, that means that as if does not exist. But I can go to another easy joint, which is joint E. Joint E, also 3 members, DE and EF and EC, 3 members forming a joint. 2 of them must be collinear. Do you remember this? This member and this member is collinear. And this member and this member, they are collinear 180 degrees, or the same bearing, or the same line of action, whatever you'd like to call it. So in this case, CE is 0 also. Here you will find that the CE is here and CE is here. So I'm still not okay. So probably this is not a good choice to start with E. Right now, normally, okay, you are saying that this is BG and CE. So I will pick a member that is not here. And this is another way of the process of elimination could be helped, since I eliminated 2 answers. And I said that the CE is here and BG is here. I look to the CG or CF. Both are the one can make a determination that either A or B. So I will go to the CG, and this is why I was very close to go to the CG, but I jumped here just to tell you that by moving here is not a good strategy. The good strategy is to identify a member that is not in the answer B. At least I can make the choice and go home happy that. So CG, since this member is 0 force member, you can look it more than one way. You can look to this joint G in more than one way. This member, if you take this joint, these 2 members, by the way, they are collinear. They are collinear. So this member is 0. That means that as if does not exist. So, and I can look this joint as 2 members are collinear, which is GF and GA. And this is the 3rd member, CG, forming the joint. So this is a 0. You can look at it that way. Okay. The other way you can look at it, that this member, if I come here at this joint and solve forces in the Y direction, this member has a component in the Y direction. Okay. These 2 members, they have no, okay, components in the Y direction. So this X and this is Y. So if you resolve the force in the Y direction, this is 0, has a component is 0. So the component is 0 will give you a 0. So you can look at either from the resolving the force of that member, which is 0, or I will apply the rule number 2, that this member as if does not exist, and in this case. So in this case, I know that CG is 0. That means that the answer this is out. So for sure the answer is A. Okay, the answer is A, and I will pick the answer A as my selection. But to proceed to prove that this member, that CF is also 0, that if you come to this joint here, these two members are collinear, and already I proved that this is 0 and this is 0. So as if these two members, they are no longer exist, so obviously this is going to be 0. So I have 4 0 force members, which is a CF. So the answer is A, as some of you indicated, and thank you. Okay, so these are the two rules. And as I told you that the 0 force members, always ask yourself, okay, any truss member, either it is responsible to carry a force, or it is responsible to carry 0. Okay, so always ask who's going to carry the force. Who is going to carry the force? Because if we are not able to answer this question, it will be because somebody has to carry the force or the load that's acting on or applied at a joint. Because as you know, trusses structures, they have certain assumptions, and we are applying the loads only at the joints, as you know, like this truss here, which probably I used it before, and to illustrate the concept of the 0 force member. So if this is A, and this is joint B, and this is C, and this is D, and this is E, and let us assume for the sake of discussion we have one force here, P, is equal 8 kips. And let us assume that this is 6 feet and this is 4 feet. Okay, and this is here. Let's assume make this also. It is 4 feet. And don't forget that all the truss problem that will be given to you, it should follow this rule: 2J is equal M plus R. This is for statically determinate trusses, where J, the number of joints, for example, 1, 2, 3, 4, 5. So 2J, 2 times 5 is equal. The number of members, 1, 2, 3, 4, 5, 6, 7. Plus R, the reactions, I have one reaction here. I have two reactions here. Two reactions here by inspection, supposed to be like this. So this is like this, and this is like this. And there is one reaction here, which is, so A sub Y, A sub X, and the E sub X. So I have 3 reactions. So 2 times 5 is 10. 7 plus 3 is 10, bingo. That means that I satisfy 2J is equal M plus R. That means that this truss is statically determinate internally and externally, and it is stable also. So in this case, I can find all the forces in or the forces in all members using the equilibrium equations, which is sigma force X equals 0, sigma force Y equals 0, and sigma moment equals 0. This is what is meant by the statically determinate, and this is what you will get on the exam, as far as I know. Okay, so can you explain rule number 1 again? Yeah, send an email. Ray is saying that he is the first time. Okay, that's fine. If this is the first time you attend, that means that your email today will be recorded in our attendance sheet automatically the moment you enroll. So after the class today, I will go to the Excel sheet or to the webinar company where I download the emails, and I will email you all the handouts I have I have 5 mini exams so far, each mini exam about 25 problems, and I emailed today 3 exams. I found them probably they are good, or problems probably you saw them before. So you will get everything. And simply, if you have anything missing, just email me, and I will be glad to do my best. It is info@passpe.com, info@passpe.com. And this is Dr. Shaheen Mansour or Dr. Mansour. Okay, and I will be glad to forward whatever I have to you, or go to our website, and the website will it will show that contact. Here it is, I believe. Email, and you can email us, and I will do all my best. Okay, that's fine. It seems that the webmaster is doing something, because this is not supposed to be here. This is supposed to be with the seismic for some reason. So I will, here it is, Dr. Mansour, info@PSP, Dr. Mansour, classes, and so on. This is my phone number, 2896412 also. It is public. You are very welcome to email me. And this is our location here in Fresno. I am in Fresno, California. So I apologize for those of you who are in the East Coast. There is a time difference, but I will do all my best to make things are early as I can, and I will do my best. So the rule number 1, some of you are asking about rule number 1. Let me explain rule number 1, and this is written in my book in chapter 4, the structure analysis book. It does have these 2 rules. So, or any book, any structure analysis book, especially textbooks, the one I use for teaching for almost 30-something years. So, chapter 4, structural mechanics, which is based on the NCEES, to the best of my knowledge, and the 2 rules for the trusses. Here they are, or I call them 2 cases, by the way. I don't call it rules. Let me get my camera as close as I can. At least you can read, and let me adjust the focus. Here it is. Let me read. I explain them using my Egyptian English. Okay. Right now, let us read the 2 cases or the 2 rules using the American English. If 2 non-collinear, and I apologize, collinear double L. Okay, this is why I said, okay, this is missing L. Yes. Okay, forgive me for spelling. Okay, if 2 non-collinear members form a truss joint and no external load or support reaction is applied to the joint, the members must be zero force members. This is the rule that you will see in structured analysis book. If we apply this rule right now to the truss I just drew, here it is. I just made one truss, A, B, C, D, E, and it has only 1 load. Okay, so this is the truss I just, okay, here it is. So I just, let me give you 22 seconds, because I think now you can tell me how many zero force members in this truss, the one you, A, B, C, D, E, okay, as you see it here, and it has only 1 load here, 8 kips. And this is 6 feet, and this is 4 feet, and this is 4 feet. And I will put 4 answers: A, none; answer B, and we can vote. We are a democratic country, we're going to vote this November. Okay, it is 2 members. Answer C, 3 members. Answer D, 4 members. Okay, so either none, 2, 3, or 4. Okay, these are the 4 answers that I just came. So I'm not going to release any name. Okay, just if you answer in your, for those who are attending the first time, there are 2 ways to communicate with me. There is in the control panel in front of you, there is a box where you can chat with me and you can write the questions. I will read the question without telling who is. Sorry, I mentioned 1 name so far, but or you can answer it. So I got 3 and 4 and and 3 and 4 and C. C is 3, 2 is B, and 4 is D. So so it seems to me we have the majority of you, they are saying C, except a couple of you said D. So I have none, I have 2 members, I have 3 members, and I have D with 4 members. Okay, so the other way to communicate with me is to raise your hand. If I am not able to understand your question, I will tell you I can unmute you. So in your control panel or in front of you, you'll find there is a control panel where you can put your hand and I will unmute you because all of you are muted. And the moment I see the hand, I will unmute you. For example, okay, there is one friend, and I will do all my best to pronounce the names, even okay, Todorvik, okay, you are unmuted now. Todorvik, yes.
Four of them.
Say it again. Go ahead, please.
Four.
Okay, so your answer is 4. Okay, thank you. Did I pronounce your name correctly? I hope. I apologize if I did.
Excellent.
Okay. Sorry, the Egyptian English, okay, probably. Okay, so this is another way to communicate with me, that you raise your hand, I will, but you can write the answer. Okay, so we have 3 and 4. We have between 3 and 4. Those are the answers that I got so far, either 3 or 4. If you look to rule number 1, which is our friend was asking that how to apply rule number 1 or case number 1, where you have 2 members, like member BC or CB, either one of them, and CD. These 2 members are non-collinear because they are not, okay, having the same bearing or along the same line of action, and there is an angle between them is not 180 degrees as I indicate. So these 2 members are forming a joint, which is joint C. And there is no load or support here, so this is 0 and this is 0. This is the application of rule number 1 or case number 1. Okay. Rule number 2, I can look to the 3 members, DC and DE and DB. 2 of them are collinear. The third one must be 0 because there is no load or support here. And you may say, wait a second, who is going to carry this 8 caps? Oh, this member BE has a component in the y direction. So this 8 caps, which is in the y direction, it will be resisted by the component. Okay, so this is one thing. So this is 0 and this is 0. If you come and join D right now and solve forces in the x direction, this is 0 and it has a component in the x, and this must be 0. So the answer is 4. The other 3 members, AB and BE and AE, they are carrying. Can you tell me what is the force in this member here in 22 seconds? The member AE. And when you are giving me an answer, you have to tell me, is it tension or compression? Okay, so this is also another thing that so this is a number of the 0 force members, but here I need the force in the member, okay, AE, member AE, member AE, the force in the member AE. Answer A, I will say it is 4 kips, okay, and this is tension. Answer B is 4 kips compression. Answer C, 8 kips tension. And answer D, 8 kips compression. So those are the 4 answers. Sorry, I'm trying to squeeze as much as I can. So when I scan this, I can scan it. And I hope that you can read my Egyptian handwriting. I try to, okay. So at least after the lecture, I will scan this with any additional notes. I will send it to you immediately after I finish the class at 4 o'clock. So we have answer A and B and C and D. The answer A, 4 kips tension, 4 kips compression, 8 kips tension, and 8 kips compression. Okay, I'm talking about the member AE. Here it is, AE. So this here, the answer is 4. Let me make number of zero force members. This is the number of zero force members. Number of zero force members. Okay. Okay. Let me pick some answers from you because I need you to participate. I need you to participate because participation is very, very important. Okay. And probably when you received my email today, I am the one who sent it this morning. And you'll find there is something in red. This is a Benjamin Franklin. Do you know who's Benjamin Franklin, by the way? Okay. Benjamin Franklin, to see, let me see if I have money or not. This morning I remember I went to the bank to get some money for a reason. Okay, so here is a Benjamin Franklin, is in the $100 bill. This is a Benjamin Franklin, okay, and the $100 bill. Okay, what did he say, Benjamin Franklin? The one I sent it this morning, the nice, wise statement. By failing to prepare, you are preparing to fail. Remember that. By failing to prepare, you are preparing to fail. Okay. If you do not prepare for the exam, I'm sorry, luck or lottery will not work over there. You have to study very hard, and by failing to prepare, you are preparing to fail. I know some of you heard this many times for me. You are preparing to fail. This is a Benjamin Franklin. Okay. By failing to prepare, you are preparing to fail. The people who passed the exam before me, when I passed the exam, and the engineers who came after me, they pass because they prepare. There is no any magic word other than prepare and they prepare and they prepare. And they prepare by understanding the concept, not because I solve it that way or because you saw it in another book this way. No, you need to understand why we are doing it. Why? Always ask why we are doing this. Because what if this has happened? What if this will happen? Because when you go to the exam in October 22nd or 23rd, you will see problems you never saw it in any other book. Okay, including my books. I've been doing this for almost 30 years. And in the past, yes, way back when the gas was 68 cents, okay, probably there used to be some problems from Dr. Kalabati or when I taught with him, Irvine Institute of Technology way back, or Lindbergh, Mr. Lindbergh, when I taught with him and wrote a lot of chapters for him in his back books. It used to be one problem or two problems from these books on the exam. Nowadays, no. They come up with something very new. Never happened before. And I will give you a sample after I finish this problem. Okay, so we need to understand the concept. But if you understand the concept, you can solve any problem exists on earth. Yes, with some difficulties. I'm not saying the exams are easy. No. I need you to, the first statement, normally I tell my students when I go to the class, I say that always shoot for the moon. And if you miss, you are going to land among the stars. Shoot for the moon, and if you miss, you are going to land among the stars. Shoot for an A, to get an A in your class. And one day you are sick or you are sick and exam was a little bit, this A can go down to B. But if you are shooting for B or C, this might go to D, and this is bad news. So always shoot. Let us shoot to get 100%. Sorry for this, but it's just, I need you to participate because Benjamin Franklin also has a very nice statement about participation. I will mention it later on. So we have 4 kips tension, 4 kips compression, 8 kips tension, and 8 kips. A kib is 1,000, by the way. 1 kib is 1,000 pounds, as all of you know. So we are using the term kib. It could be just a K like this, or it could be written like this. Okay, whatever. The answer. Okay, I got some answers. 4 kibs, and I got some answers. Answer D, 8 kibs compression. Okay, so Unfortunately, both of them, I believe, are not correct, and I will show you in just a minute. Let me take it back. Probably I misread. Let me make sure that what I'm reading the answer, because some of you put the letter, some of you put the values. Okay. One of you. Oh, you are using the C for compression. Okay, not the answer. Okay. So 4 kips compression and 8 kips compression, and one of you who said answer is D, which is 8 kips compression. No, both of them, and we'll go over this. Okay. Let us look to this. We have a force here. I will answer you, my friend. Just give me a chance. Some of you raise a hand, but let me just let me go to my drawing board and try to do this. At least I can explain it a little bit more, because I needed to understand this very well. So this is the truss I just made, or I just construct. I don't make anything, I just construct something and make it a little bit of proportion. At least you get a feeling of. And so this is a roller support, and this is a hinge, as I draw it here. Be careful with the supports, because supports are very important. This is a roller support. It has only one reaction, perpendicular to the contact surface between the support and the surface. And I said that there is only one load acting here, which is, I called it P, 8 kips. And we named the joints as A, B as in boy, and C, and D, and E. Is this correct? Yes. And this is 4 feet. Sorry, my drawing is not to scale. This is supposed to be moved one step here. And this is 6 feet. Sorry, I should move this a little bit, but forgive me for that. I should move this line. And we said that we already proved so far that this is a zero force member, and this is a zero force member, and this is a zero force member, and this is a zero force member, by applying these four. These are these 2 cases or 2 rules. Some books they call it cases. I call it 2 cases or 2 rules, whatever. And my question was, what is the force of this member here? This is a vertical force. So if I set my coordinate system X and Y as shown, so in this case, this is a roller support. A roller support has only one reaction, and this reaction is perpendicular to the contact surface, always. And by inspection, you will see that it has 2 components, one in the X and one in the Y. So A sub Y, I put it to be up, or if you'd like to put it exactly here, I have no problem with that. Let me modify my location of this reaction, just at least it will make more sense to you. So if you put this here as an A sub Y, and as you can see here, I draw it up. Why? Because we have 3 equations, the 3 equilibrium equations. Sigma force X is equal 0, and sigma force Y equals 0, and sigma moment equals 0. So I have one force, 8 kips coming down. I must have this 8 kips going up. Equilibrium. Otherwise, this truss will start to move around. Have you ever seen a truss on the street? No. Trusses always are stable and in equilibrium, because action and reaction. So I know this from here by inspection, by applying the sigma force Y. I have here 2 reactions in the X direction. One reaction is going to be this way, and the other reaction going to be this way. And these two reactions are equal magnitude, opposite direction. Because this force is pushing down, it tries to take this truss out. It will create a clockwise overturning moment. How much is this reaction, by the way? A sub x. A sub x. Can you tell me what is A sub x in 22 seconds, please? And the A sub x. In fact, you will find that A sub x is also 8 kips. And A sub x is also 8 kips. If you sum moment here to find A sub x, so 8 times 4 is equal A sub x times 4. 4 and 4 are equal. This way I made it that way. So this is 8 kips, 8 kips, 8 kips. What a coincidence. So if the force right now in the member AE equals what? This is what I'm asking. This force in this member here, AE, how much? This force, by inspection, you don't need to do any analysis. But I will take the method of joints and apply this force here. It must be this way. The arrow going this way, and the arrow is going this way. And this force here, the force in the member AE, is equal 8 kips. Tension or compression? Tension or compression. This is, so we have 3 scenarios for any force that exists on any truss member. Either a zero force member, and we show the member with 0 like this, or a member, it could be under tension, or a member under compression. For tension and compression, there are 2 definitions. I prefer to stick with one. I can explain both of them, but I needed to remember only one. I prefer always with respect to joint. This is a joint, and this is a joint, and this is a joint. Any member, any truss member is connecting 2 joints, or span between 2 joints. You will never find member just a joint and hanging somewhere here. No, it has to continue all the way to the other end to form a joint, because these are the assumptions. All members are connected together with a frictionless joints. If you remember, go back again to structural analysis book, you will find there are 7 assumptions for trusses when we analyze them, and one of them. So I prefer with respect to joints. If the force in the truss member pulling the joint, going away from the joint, they agreed that this is a tension. If the force going into the joint, pushing the joint like this, going into the is compression. This is the easiest definition, or the easiest way to identify a tension or a compression force. If you like to remember the other, this is with respect to joints. With respect to joints. And it is true with respect to members. Okay? But if you remember with respect to joints and apply it, so if the force is pulling the joint, here is a joint and here is a joint. In our case, what is the arrow here? The arrow is pulling this joint A here. So it is, the force in this member is 8 kips tension. And this was the answer C. Not 4 kips compression. No, 8 kips tension. So this answer is the correct answer. Okay. Similarly, what about the force in the member AB? I determined the direction of this. So I have a force going this way and a force going this way. So the force in this member also, it is 8 kips, and also it is a tension member. The force in the member EB, the force in the member EB, I will wait for you. I need somebody to give me. So already you found the forces in this member and this member and this member, which is 0. This is and this by inspection. Okay, this is by inspection. What is the force in the member BE or EB? Either end, by the way, should be correct. I need the magnitude. How much is the magnitude? And you have to tell me it is T or C, because it's not a zero force member. The force in the member BE. Let me move my camera here. At least you can see the entire truss. I will give you 1 minute from now. I know you have 6 minutes on the exam, but we need to be ready and we need to be fast, because we need to get 100% of the exam to guarantee that we will pass. So this is the second member I am shooting for. Okay, the 1 minute is over. So let me check to see if anybody of you help me. Okay. Okay, I got too many answers, too many different answers. 2 of them so far are good or correct. Okay, first of all, by inspection, I know this member is 0. The vertical members BD is 0. We got it from here. So this member, the slanted member, it must have a component in the X direction and component in the Y direction. So the component in the Y direction, it must balance this 8 kips. Otherwise, the truss will start to move. That means that if this is going down, this must be going this way. Do you agree with me? That means that it must be what? A compression. This is the first answer I need you to be aware of. That the member BE or EB, the force is compression. Equilibrium. Something coming down, it must be resisted by something going up. This is something going to the right. This force in the X direction will be to the left. If you resolve the force in the X direction, will go, so equilibrium. If there is no equilibrium, you will see a truss one day walking on the street, demonstrating with the people who are demonstrating right now nationwide, as you know. And hope that will not happen again. Okay, so this is the direction, because inspection is very important and understand the concept why. The second is the component. I know the slope of this line or this member is 1 to 1, and this is square root of 2. So if I take this joint out, let me take joint, because there are 2 methods, or you can make it 3. Method of analysis, or a trusses method of analysis. Methods of analysis. Essentially, there are 2. Some books, they put it in 3. Since I use many structure analysis books for my 30 years teaching as a professor here in CSU Fresno and in New Mexico State, in Las Cruces in New Mexico, each author or each professor is presenting the case, but some professor, they make a little bit of. So method of joints and method of sections. And there is another method, it came from them, it's called cut and sum method. But essentially it is a method of sections. Method of joints, I needed to remember, never pick a joint has more than 2 unknowns, not 2 members, be careful. 2 unknowns. Why I'm saying that? I'm not inventing anything, by the way. All this knowledge is available in textbooks. I just am presenting now. Why I'm saying that never pick a joint has more than two unknowns, not two members, because I have only two available equations: sigma force x equals 0 and sigma force y equals 0 for method of joints. What about the third one? Oh, I mentioned there are three equilibrium equations for 2D system. This is a 2D system, by the way. This is a 2D. Any 2D system exists on Earth, it does have these two equations plus any conditional equations if there is any. Because method of joints, all the members are concurrent force members. They are meeting at a common point. So the moment equation has no value because there is no moment R. But method of sections, we have three equations. We have sigma force x equals 0, sigma force y equals 0, and sigma moment equals 0. So the moment equation, it does exist for the method of sections. And I will talk about method of section shortly. Cut and sum method is exactly the same as the method of section. You cut and sum the forces in the x direction, y direction, and even you apply the moment. This is why we have a 3. So if you look to this joint B as boy, okay, if you take this joint out, what is the method of joint? Say that, come here, Mr. Mansour, and you are going to cut this joint with a scissor. You take it out. Isolate this joint, but I am violating the rule I just mentioned, never pick a joint that has more than two unknowns? No, I did not violate that because this is 0 and this is 0. Even before finding the force in the member BA, I can still take the joint because already I have two members already zeros, so I have only two unknowns. So if I take this joint out, and forgive me, I will take it to the other. So joint, method of joints, I will take joint B as in boy. You will find that the joint, when you cut it, you need to take all members and all forces. This is the famous joint B, and here is the 8 kips, and this is BC, and this is BD. Sorry, let me make this D, and this is the BE, the one we are interested in, and this is BA. And this is where I cut. So I cut the joint, and I took it outside as a free body diagram. Already I know that this is 0 and this is 0. And I know the slope of this is 1, 1, square root of 2. And I know for a fact this force must be going into the joint because the component in the y direction must balance the 8 kips, x and y. So in this case, I can apply. Did I forget anything? I have to, when I pick a joint, you come with a cut, you cut the joint. Imagine you come with a scissor and cut it and take it out as a free, but this we call it a free body diagram. Free body diagram. Right now, without knowing the force in the member BA, which already I know it because of from the other joint, I can say some forces in the y direction equal 0. And I have to say direction. I know the direction of the force, but assume for the sake of discussion, I don't know if it's tension or compression. Let me reverse it. By inspection, I know it's a compression force. But let me assume that I don't know. When you have too many members, by the way, sometimes we don't know. Let's assume that I assumed it to be this way. What is this? This is tension. I assume to be tension. It is pulling the joint, pulling. Okay, pulling the joint. This is the tension member. Let's assume when I sum force in the y direction, I have to assign a direction. Normally, I go with this agreement here. My grandfather and your grandfather agreed on that this is positive and this is positive. Let us respect our grandfather's coordinate system that they selected here for the 2D. So I will say minus 8 kips coming down because I assumed anything goes up. And this here has a component in the y-axis set minus the force in the PE divided by the hypotenuse, which is the square root of 2, multiplied by the vertical component 1 equals 0. I will solve for the force in the member BE. You will find that this is equal minus 8 kips times the square root of 2. And this will give me the answer that was given by one of you. So 2 square root and 8 times, it is 11.31, negative 11.31 kips. What does it mean, this negative? Negative means that my assumption is wrong. Okay? This is a very easy one. I can, by inspection, I say that this is should be compression. So if I put it in the proper direction, which is a compression force, and if I apply this equation, the component is going up in the same direction, so this becomes positive, and automatically it becomes positive. That means that my assumption is correct. But as I told you, if you don't know the direction, either for a reaction or for a force in a member, assume it to be tension compression, or assume it to be right or left. For example, here, these two reactions, I know that because by some moment here, so this is a clockwise, this must be counterclockwise. And by inspection or by practicing, you will be able to find all these things. So the force in this member here, finally, this member here, BE, is 11. So the force in the member BE, as a final answer, is equal 11.31 kips, and it is C, compression. This is the answer. So please, when you receive these notes, after I scan it and send it to you, please look at it and let me know if you disagree with me or you have any comment or suggestion, or oops, I wrote in the opposite direction, sorry. That's fine. So this is a typical truss problem, and I have tons of them, tons of problems since for over 30 years I have. Okay, it seems to me for some reason I send you something that I should not, is not, it seems to me I send you the wrong one, because the other problems, it does have the same, but my intention not to do that. I will correct it and send it to you. A problem like this, problem number 11. Problem number 11 of the same exam. A 1/2 inch 7-wire pre-stressing strand is to be stressed in the pre-tensioning bed showing 14 tons jacking, okay, jacking force. The length is given to be 310 and is asking for the strand properties indicated. What is the elongation? As you know, concrete, which also I will talk about concrete and how to mix concrete and how to adjust for mixing, properties of concrete, all these things are very important. This is material section. Concrete will have different ways to classify concrete. Concrete is a mixture of 4 components. First of all, it is a fine aggregate, which is sand. Any concrete exists on earth, it has these 4 basic ingredients, and after that it has some additional. Coarse aggregate, which is a gravel, plus cement, and we have 5 types of cement. You should know what type of that. And finally, water. Those are the 4 basic ingredients for any concrete exists on earth. Sand, gravel, cement, and water. The most expensive item in this, by the way, is the cement. And the most important relationship is the water cement ratio, W over C. And this ratio by weight, water over cement, is a ratio by weight, not by volume. What does it mean? It means that how many pounds of water over how many pounds of cement. Or sometimes we express the water cement ratio by how many gallons of water per a sack of cement. We know a sack of cement is 94 pounds. It's not 100 pounds. They made it 94 because this is the volume of 1 cubic foot. So a sack of cement is 94 pounds. And a gallon of water, it is 8.34 pounds. Oops, 8.34 pounds. So if you go to the grocery store, grab a gallon of milk and weigh it, and tell me next time when we meet, if the gallon of milk is weighing more than 8.34 pounds, this is water, which has higher density, the water or the milk. Just grab a gallon of water, a gallon, or if a gallon of water, by the way, okay, you're in the store, nobody will charge you for that. You grab it and weigh it and see how many pounds. And we can consider the weight of the plastic, okay, just for your knowledge. Okay, so still the ratio by weight. So either this, and I have many problems related to this topic here, because this is sometimes it comes in the morning, sometimes it comes in the afternoon, especially for construction group, okay, or transportation also. And we should know how to adjust for surface water and so on. We'll talk about this later on. Sorry, my voice, it seems to me that I was. So for concrete, we can classify concrete more than one way. We can say this material, it could be either air entrained concrete or non-air entrained. This air entrained concrete, this is the type of concrete that we intentionally create air bubbles into it using something called admixtures. I will talk about it later on, but it's non-air entrained has some air is called entrapped air, not entrained. And there is a very important relationship. Any civil engineer, even while he is dying, he should remember that. Okay, forgive me by saying that. If any civil engineer, if you ask him about this, and even while he is dying, if he didn't answer, don't put him in the grave. Okay, just take him back. I tell him you have to, no, just to wake you up. Okay, no problem. I know you remember it, but this curve or this relationship is between the water cement ratio and strength. And the strength, I'm talking about the compressive strength. So this is the water cement ratio, and this is F sub C prime, which is P over A, which is a 28-day compressive strength, and I will talk about it this later on, why 28 days. So there are two graphs or two curves, one for air entrained and one for non-air entrained. Here is one, and here is another one. This one here for non-air, and this one here for air. For any given water cement ratio, the water cement ratio can go as low as 0.23 or 0.24, and it goes as high as 0.7. As the water cement ratio increases, what does it mean? Mean the amount of water is more compared to lower water cement ratio. You are putting a lot of water, so the higher water cement ratio, the lower the strength. So for any given water cement ratio, If you go up vertically like this for any given water cement ratio, 0.4, 0.5, whatever the ratio is, if you come here, draw a vertical line, you will find for the non-air, the strength is higher compared to air. Okay, so if you compare these two values, the strength here, this will intercept here and this will intercept here. So for non-air will give you a higher strength because the strength is increasing this way. So we are adding air intentionally for the air entrained concrete to increase what is known as a durability. A durability, and we'll see what is the durability later on. So we are creating air bubbles intentionally into the mix. We call it air entrained concrete. I know I'm losing strength for any given water cement ratio. These small microscopic air bubbles between 0.1 and 1 millimeter. I am losing strength, but I'm gaining something is called durability. So for any water cement ratio, you will find that I need you to know that the relationship between the strength and the water cement ratio for two types of concrete, for air entrained and non-air entrained. And we'll talk about this in more depth. There is another way to classify concrete. It could be either plain concrete, plain, which is unreinforced, or it could be reinforced, or it could be a pre-stressed. This is another way to classify concrete. It could be either a plain concrete without any reinforcement. It could be reinforced with rebars, like this rebar here. Different sizes of bars, reinforcing rebars. This number 11, for example. And the other one is a pre-stressed. A pre-stressed. A pre-stressed, we are using this. Probably some of you dealt with this. It's called the pre-stressed cables. Strands, 7 wires, they are wrapped together like this, and we pull them, and I'm going to talk about what's called the pre-stressed strands or tendons. Okay, so this is another way to classify concrete. Concrete also could be classified as normal weight concrete, normal weight, or lightweight. Lightweight. So normal weight and lightweight. And each group can be taken separately, and we can talk about it, and this probably will cover it during the discussion, more discussion about the, but let me talk about the pre-stressing, which is related to this problem here. Problem number 11, you have a force applied is 14 tons, and we're applying, this is the modulus of elasticity, E, and this is the cross-sectional area, and the length is 310, and he is asking if we apply 14 tons to these 7 wire strands, it is half an inch diameter, the one I showed to you. If you calculate, by the way, the area for half an inch is equal by d square 0.5 square by d square over 4, you'll find this is 0.1963 inches square. If you calculate the area for a solid bar that half an inch diameter, and you can try this, your calculator, please do it, and you'll find this number, if I remember correctly. Let me do it. Yeah, it is 0.5 square and by times 4 divided, yeah, 0.1963. Yeah. This is the cross-section area if you have a half an inch. And he said half an inch. But these 7 wire strands, they are not solid, by the way. They are, okay, in fact, we can take them out, by the way. We can disassemble them. These 7 wires, I don't know if you did this or not, they are 7. I can assemble them. Let me take them out. Here it is. I used to give this to the students. And I tell them that if you can put it back again in 22 seconds, I will give you, okay, extra 1 point in your final grade. Okay, just here it is. 7 wires. They are rounded together or they are assembled together. Here we go. 7. 1, 2, 3, 4, 5, 6, 7. Okay, so they are, okay, they are forming these. Let me put it back again. So we start, okay, to put it back again, start with the straight one. There is, okay, 6 of them are curved and there is 1 straight. So I will start with the straight member, which is, okay, 0. And after that, I will start to wrap one over the other. And you can do this, okay, very quick. And this is, so the 7 wires, they wrap around this, the 6 wires, they are wrapped along the solid one in the middle, the solid straight one, but they are not, there is some gaps between them. This is why the area is not the 0.1963. In fact, it is the, I still have 1 to go. Do you count how many seconds did I take? Okay. You are faster than me, obviously, because you are younger than me. So this is the 7 strand. So why the area is smaller, by the way, here area is 0.153 versus this. This is if it's a solid bar. But there is some air bubbles here and they are wrapped against each other, so are not. Okay, so the effective area is 0.153, just to be aware of that. I don't like you to calculate the area and say, oh my God, why 0.1963 is not listed here? Because of the shape of these wires. They are wrapped like this and they account for this, so they give you the effective area. So this is what was known as pre-tensioning. Because the pre-stressing, there are 2 types. When we are doing pre-stressing concrete, a pre-stressing, there is pre-tensioning and post-tensioning. And post-tensioning. There are 2 systems. Each one has advantage. I discussed this in depth with construction group. So this is an AM problem from my point of view. It could be an AM problem. So he's asking how much the elongation. All bodies are deformable bodies. So when you are having any member or any body, you are applying a force, either tension or compression, it will deform. We remember the letter E. E is the modulus of elasticity. And the E is the slope of the linear portion of the stress strain curve. Again, any civil engineer should remember this. This is the stress strain curve, epsilon, and this is sigma. And let me draw the entire stress strain curve. But the linear portion, the slope is, which is sigma over epsilon. We call it Hooke's law. Please remember this. So E is equal sigma. Sigma is equal P over A, force per unit area. And epsilon is the strain, is delta L over L. Here I can solve for delta L. Or sometimes we write it like this, delta. Or even some books, they call it delta L. Is equal PL over AE. And this is the equation I need you to remember. It came from Hooke's law. Hooke's law. So the deformation under axial load is equal PL over AE. Can I apply it here? Yes, piece of cake, here it is. So delta L or delta L is equal to, P is 14 tons. How many pounds in 1 ton is 2,000 pounds per 1 ton. Units are very important. B, what is the length? Length is the 310 feet times 12 inches per foot divided by AE. A is the cross-section area is given 0.153 inches square times E is given to be 27,500 KSI or 27 million. So it is 27, and this is pounds, so 27,500. I multiplied by another 1,000. This will give me PSI, pounds per square inch. If you do this simple calculation, do it with me, please. So it is 14 times 2,000 times the 300 times 12 divided by 0.153 divided by the mass of elasticity. We're supposed to get one of these numbers and see if, okay, so 14, did I miss anything or I put anything wrong? So it's 14 and 2,000 times and the 300 times 12 times 0.153 divided, and 27,500 and divided, bingo, I got 24.76 inches, which is very close to the answer D, as in David or doctor. Okay, so the point here, I would like to make two things. Number one, I needed to remember this equation, Hooke's law. This is called the modulus of elasticity E. I know we are using the letters a lot, modulus of elasticity. Normally, we take most of elasticity for steel around 29 million psi or 30 million psi. Here he gave it you 27,500,000 KSI or 27,500,000 psi. No problem. Whatever number is given to you. If it's not given, normally we take E. The E steel by default, E steel is equal to 29 by the steel manual, 26 million psi or 29,000 KSI. Or, by the way, if you are using metric, is 200 GPa, gigapascal. We need to be familiar with all these units. Units are very important, by the way. Units are very important. Units are very, very important. Okay. NASA is a great organization, and as you know today, the SpaceX with NASA, Elon Musk, they have the capsule already landed to the space station. This is the first flight from the US in about 10 years. So it was a great success. And I was watching, I like NASA channel. I watch NASA channel a lot. So NASA is a great organization, and don't misunderstand me. Okay, as I said, that they just achieved something very good today by these two astronauts. Okay, they landed, okay, or the capsule already reached the space station. This is 1 hour before they landed, I left. So I hope that everything done or landed peacefully. But at one point of time, NASA lost a rocket, okay, or testing they were doing for a rocket, and they lost this rocket because of units. It's about $10 million rocket because the units between metric and English, or the SI. So units could be a source, but don't misunderstand me. NASA is a great organization, but they are a human like me and you. They do mistakes, but I hope that no more mistakes. So, so you have to balance the units. As you can see here, and when you receive this, you will find tons cancel with tons. Feet cancel with feet, and what's left is inches. This is inches square. Pound will cancel with pound. And this is pound per inch square. Inch square will cancel inch square. What is left is inches, which is the final unit. And this is what? He put it here in inches. Units. Pay attention to the exam. When you are reading the problem, look to the 4 possible answers and look at what are the units and take care of the units immediately. It's called balancing units. I remember way back in Las Cruces, New Mexico, when I was studying over there, doing my master and my PhD over there. some professors insist to have to do this. If you didn't do this, you get 0 in your homework. You have to balance the unit. Balance is called balancing units. Don't say that I will do it at the end. No, do it immediately. 14 tons, I converted to pounds because I know this is in kips. Okay, so it's not in tons. So I said 2,000 pounds per ton. 310 feet, this is the length. I need the answer to be, so it's 310, 12 inches per 1 foot. It immediately, because if you delay this to the end, believe me, you'll get confused. It is a common mistake, and units could be a source for an error during the exam. And generally speaking, by the way, based on my experience for the last 30 years or so, when I hear all these horrible stories from the engineers who took the PE exam, if you get an answer that is completely away from the given answers by a factor of 10 or 20 or 100 or something, look to your units. Probably you forgot to multiply or divide. So units could be an indication that your answers are completely away from. So the answer is D for this one here, and I will scan this color. I will send it to you in color. And okay, let me see if there is anything I can pick here. If you look to this problem here, and after that, I will switch to another area because I need to cover as much as I can today. And as I said that, I will look to my schedule and see. So today is the 30th. No, the 31st. Sorry, it was yesterday. So we still have two more meetings, which is June 6th and June 20th. But I owe you a period. I believe I missed the 2nd or the 3rd. I remember it was. I can't remember what was the reason, but I was not available. Something urgent came and I miss one of these sessions, if I remember correctly. So I will add one more session here to make total 7 sessions. So, and I will look to my schedule because I have transportation group next Sunday. I will meet with them on next Sunday and the following Sunday and the following Sunday. And the construction group, you are very welcome to attend. All of them one ID, by the way. You need just, you enter the ID once and that's it. So so next week, if you'd like to join transportation, you are very welcome to come. If you are not interested because you are taking construction, you don't have to come. But you will receive the invitation because the computer, this is their computer, not my computer. The company that I'm they hosting my webinars, and these webinars are recorded, by the way. I'm recording the session right now, and somebody will take the recording tomorrow and load it on our server. Not our server, sorry, again, their server, and put the link on our website. Okay, so when you go to our website, you will find that, let's go to the home page, and you will find under free workshops, and you click on it. It will take you to surveying. There are some sessions here. Civil breadth, here it is. There are 3 so far. So as I told you that I missed one session. So if you click on it, it will start. Those are the sessions, and construction and the transportation and the seismic. So, and I hope that everything is working fine. If you have any technical difficulty, please let me know, and I will ask my staff to work on it as soon as they can. But you have to be extremely patient with me and with them because they are working from home. They are working remotely. So the productivity is not as if they are in the office until this coronavirus is gone. I don't know. I hope it will be gone very soon. So, and I believe they also, they told me they created a channel on YouTube. So you can go to YouTube and look for Dr. Mansour, a channel. Maybe, I didn't try, believe me, I'm so busy. They told me that they have a channel for me right now. Here it is, by the way. I found it. Here it is. So this is so registration will start June 1st. Exam take place October. So the statement I was telling you, here it is, and something. Okay. So and if you sign up for the free classes, just click on it, and you already signed, so you don't have to do anything. Okay. Other than that. Let's take a few minutes break. Right now is about 2:30, 2:31 California time. So give me about 10 minutes, and get some fresh air, please, without any coronavirus. Just we need fresh air only. We need this coronavirus to be gone completely. So stay safe, put your mask, and get some fresh air only, okay? Please, okay? And join me after 10 minutes from now. So it is 2:31 right now. So 2:41, I will be back. Thank you very much. Okay, welcome back everybody after this short break. Let's continue our discussion here. And if you look to this problem here, which is also from the fall 2017 exam, related to deflection. Deflection calculations are very important. Problem number 16. Deflection calculations are important, and nobody will ask you to remember the equations, and nobody will ask you or expect that you will develop equations. But we should be able to locate or identify the proper equations for deflection. As you know, deflection since all bodies are deformable bodies, so any member, either a concrete or steel or wood, will deform under the effect of the loads. So if you do have a cantilever beam like this, a beam that fixed from one end and free from the other end, we call it cantilever beam. And this cantilever beam, whatever the material is, if it is subjected to a load, either a concentrated load or a distributed load or both, will deflect. Like for example, this, if you have a load P at the free end, and this is L, and the cross section of the member is given as B and H, and whatever the material is. So I am expecting that this member under the load at the free end here is going to come down like this. It's going to deflect like this. This amount here, we call it deflection. And this is the maximum deflection. Delta max, some books they are using V max. So the maximum deflection will be at the free end, and the deflection here, by the way, at the end A, if this is A and this is B. So at end A is going to be 0, and the deflection is going to be increasing as it's parabolic, as you can see. So this deflection or the vertical deformation, like this straight edge here, I have a straight edge, and if I hold it from one end and push it from the other end, as you can see, is going down. Here it is. It will tell you the deflected shape. So this deflection, I needed to understand the concept, because they ask some conceptual questions and calculations. Concept, if this beam, let's assume for the sake of discussion, made of steel, and one time we use steel that has F sub y of 36 KSI, and I change the steel to make it F sub y 50 KSI. I change one time this beam is made of steel that has a yield stress of 36 KSI, and another that has 50 KSI. They expect the deflection will increase or decrease. So it shows changing F sub y from 2, the deflection will, number or answer A, increase, but B, decrease, C, no change, or D, not sufficient information. And let me repeat the question again. A beam, a cantilever beam as shown, where the A is given, the area is given, and L is given, and the load is given. The only change I'm going to make, the only change, this is the only change, changing the F sub y, the yield stress, because as you know, the yield stress is given in the steel manual. You remember the steel manual, the black or the red or the green, whatever is. There is in chapter 2, you'll find that there are some tables here, and it does have these values for the, let me see if I can locate them quickly. Okay, here it is, F sub y and F sub u. F sub y, the yield stress. F sub y, here it is, F sub y. Okay, and this is 36, for example. And some steel, okay, they have the 50, here it is. So I change F sub y from, this is the steel manual, this is the 14th. They have the 15th edition right now. It's not required for the AM, required for the PM, for the structure group, for the, construction and the structure. But anyhow, the point is, changing the yield stress from 36 to 50 KSI. This is the only thing I change. The deflection will increase, or it will decrease, or it will no effect at all or no change, or I did not provide you with enough information to make or to give a correct answer. What do you think? A or B or C or D? Let's vote. We are a democratic country and we're going to vote again November, this coming November. Don't forget to mark your calendar. The exam will be over October 22nd and 23rd. So Thursday and the Friday, October. So you have to, from October 23rd, which is Friday, you have time to think about who is the best candidate, unless if you already decided and make your mind. Okay, or made your mind, sorry, already. Okay, so what's the answer? A or B or C? Okay, I'm talking about this question right now. So I'm trying to get feedback from. Okay, so is a increase, decrease, no change, or not sufficient information? Okay. 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 So I get mixed answers. I get A and B and C and D. Okay. If we know the relationship between this deflection, delta, either the delta max or the general equation, and the parameters that will affect the deflection, I will be able to answer it. And this is in the steel manual. I'll show it to you the cases, which I put it in my textbook or textbooks, but I put it in a order way or arrange it in a way. So this delta max, for example, either this or some books, they put it that way, delta max, which is the maximum deflection. And this is also applicable to the general equation, or V max, as some, the NCAAs they are using, is equal to, for this specific case, it is this equation, as you remember, PL cubed over 3EI. This is the equation. If you have a concentrated load acting at the free end, it is BL cubed over 3EI. We derived this equation in school, if you remember, double integration and moment area method and all these things. But in the steel manual, they have it under the section of beams. Okay, if you go to the beams, you will find at the end of the section of beams, you'll find that we have a lot of cases. And here it is, the deflection, shear, moment, and deflection, and all these things. So you will find the cantilever one. Let me show it to you. But as I told you, I put it in my books, okay, in a different order, at least to make it easy for everybody. Let me, here it is. This is a case number 22 in the current edition, or the fourth. Here it is. It is a cantilever fixed from one end, and sorry, the text is so light, but let me zoom in here. At least you can see it. And this is the equation I just wrote. PL cubed over 3EI, the delta max at the free end. This is the general equation, delta at any x, but also the function of p and ei and l and x, whatever x is this. So the f sub y, the one I was talking about, is not a function, is not a parameter of this equation. So it doesn't matter if you change the steel yield stress from 36 this, no change. The deflection will change only if B changes, L changes, E or I. I is the moment of inertia, which it depends on the cross-section area, which is BH cubed over 12. For this rectangular section here is BH cubed over 12, as you remember from. E is the modulus of elasticity. E is the modulus of elasticity. Okay? So, and the product EI is very important, by the way, because they might ask you, EI, it does have a name. EI, it does have a name. The product modulus of elasticity times the I, it has a name. Do you remember the name? It's called deflection rigidity. Deflection rigidity. Because if you go to the NCEES, you know, the blue books, the practice exams, they might come up with a new set in July, maybe. I hear that. There is one question, if I remember correctly, in the AM section, in the AM, and this is the AM, and they are asking, here it is, question number 118. They are saying that the beam sections shown are fabricated from 1/2 inch by 6-inch steel plates. Which of the following cross sections will provide the greatest flexure rigidity? Here it is. This term is very important. Flexure rigidity. Did I say this? Oh yeah, I wrote it correctly and spelling correct. Flexure rigidity, this is the EI. Okay, if I don't know what the flexure rigidity is, okay, I will be having difficulty to answer this question, because we need to know which section has the highest one. This, the L shape, or the angle as we call it, inverted T, and the I-beam upside down, and the I-beam or the W shape in the regular. E is the modulus of elasticity, and he said this is steel plates. So any steel blade, it has one which is 29 million psi, as I wrote it shortly. Or if you like to remember, at 30 million psi, I have no problem with that. psi, or 30,000 ksi, cubes per square inch, or the 200 gigapascal. So the steel manual is using 29 million. The one I showed you, the steel manual. Any addition, the green or the blue or the red or the black, it does. Let me just close this here. So E is constant for all of them. So the only variable left for me is I. I is the moment of inertia, or the second moment of area. We call it moment of inertia, as you know. Moment of inertia. It seems to me somebody's trying to use my computer. Yeah, probably one of my assistants is trying to get access to the computer from home. So hopefully that he will recognize that I have a class, because he doesn't know that the class has changed from yesterday to today. I didn't tell him. I got really busy, so probably I will. If he tried again, he will. So the moment of inertia or the second moment of area, by the way, we call it second moment of area. Second moment of area. Let me text him very quick. At least he will not try one more time. At least, yeah, it's my fault. I didn't tell him that I moved the class. Okay, so second moment of area. Some books, they don't like the word inertia because inertia normally associated with mass, but this is the most common name, moment of inertia. So the flexure rigidity is very, very important, the EI. And here it is, the same problem. Okay, the same problem. It could be asked, instead of asking you which one has the greatest flexure rigidity, he will tell you under the, okay, under a load or under, he said that these sections are used, let me reword the question, okay? These cross sections were used to construct a cantilever beam of 40 feet. He will say that. And this beam is subjected to a concentrated load at the free end of 20 kips. Which one will give you the greatest deflection? Or which one will give you the smallest deflection? Smallest deflection. You see? Which one will give you the smallest deflection? I know the deflection delta is inversely proportional to 1 over EI. I need you to know that, because here it is. This equation, delta is equal BL cubed over 3EI. The problem that I will go over, which is it does have a distributed load, the one problem number 16. This is a simply supported beam, and here is the cross section. A single span beam, concrete beam, the cross section is given. Okay, it is 8 by 14. Normal weight concrete, F sub C prime is given. 4,000 psi was used to construct the beam. Neglect the weight of the rebars. They have some rebars here. What is the maximum deflection due to the beam weight? This beam is going to deflect under its own weight. Is this correct? Yes. It will deflect. How much is the maximum delta max? And the length is given, or the span is given. So delta max for this scenario is equal to WL to the fourth, or the 5WL divided by 384 EI. Another equation. If the load is a distributed load W, it is 5WL to the 4 divided by 384 EI. Let me double check, because sometimes I forget, because as I'm getting older, so sometimes I forget some equations, but it will not hurt to, this is a simply supported beam carrying a uniformly distributed load, and here it is. It is 5, here it is, 5WL to the 4 divided by 384 EI. All this is given, I give it in my book in a form of tables, but I put them in a form of cases. I group them together. Statically determined, statically indeterminate, and I try to make it, group them together at least. That will be much easier during the exam, because the cases in the steel manual, they are not arranged, okay? And the way that I believe it could be much easier for you. But you are very welcome to use whatever book or books, okay? So again, this here, delta is inversely proportional to 1 over EI. Mean that the larger the flexure rigidity, the smaller the deflection. I need you to know that. So instead of asking in the blue book, the NCEES book, and instead of asking which one has the greatest EI or the flexure rigidity, he didn't define the flexure rigidity for you. He assumed that you know it. I'll give you different sections. He'll say that, okay, the following 4 sections were used as a cross section for a simply supported beam or a cantilever beam carrying a distributed load or uniformly load, whatever it is, and the length is so and so. Which one has the smallest deflection? The beam that has the largest EI has the smallest deflection, which is as this goes up, this goes down. They are inversely proportional. Do you see that? So the same question could be asked in a different angle. So not necessarily that they will ask you this question again in the same format as given in the CWES practice exams, that, as all of you know, that these and these problems are so easy compared to the actual exam. The actual exam, the problems are difficult. This is why I always shoot for the moon. And if you miss, you are going to land among the stars. Okay? So this here is, so the first thing that you might be given a problem with that, either to calculate the deflection, and this is what we are looking for. Or he might ask you, they give you the same scenario, but to give you a conceptual question. Where is the maximum deflection? What will happen if we change this concrete? Instead of F sub C prime, instead of 4,000, I make F sub C prime of 5,000 PSI. What do you think? If I change the F sub C prime, as you know, F sub C prime is a 28-day compressive strength. When we prepare these cylinders, the 6 by 12, do you remember these cylinders at school? Okay, the 6 inches in diameter and 12-inch in height. And we cap it with sulfur and we crush it with the load P. Let me bring in my chapter 7 of my material section, which we covered portion of it, but when we resume again in July, we will continue. Let me see. I believe I have a picture just to remind. Here it is. Do you remember this cylinder? Here it is. Materials. So this is a concrete cylinder. This is a sulfur compound, and this is the upper head and the lower head of testing machine. And we crush it. This is 6 by 12. 4 by 8 is also used to get the F sub C prime, which is basically F sub C prime is P over A, this axial load. What the maximum load, and this is after the failure forming this shape. It is a pyramid shape like this, by the way. And there is a reason for that we can discuss about this. So this is the cylinder test. There is another test, is called the beam test, which is to get the modulus of rupture, MOR. And the third test is the splitting tensile strength, or the Brazilian test. So you might be asked about, this is a setup, and this is after failure, how it looks like. Okay, so the question is, when we are determining or calculating the maximum deflection, I will need to get the proper equation, number one. And this is the equation as I wrote it down and I double checked it with the steel manual. I need to get the parameters. 5 is 5, constant, came from the integration and all these fancy equation. W, what is W? W is the unit weight per linear foot. Here he did not give it to me directly. He asked you to calculate the unit weight. So I will take 1 foot and I say W is equal what? It is 8 inches. So 8 inches divided by 12 inches per foot. And 14 inches is the depth. So 14 inches, and I will divide this 12 inches per foot. Units are very important. And I will take 1 foot length. So this will give you cubic feet. And I know this is concrete. He said normal weight concrete. Do you remember the concrete classification I talked about? We have lightweight, this one classification, and the other one normal weight. Normal weight. Normal weight, gamma for normal weight between 145 to 150 pound per cubic foot. You can choose any number in between. Normally we go with 150. If you like to use 145, I have no problem with that. The answers are widespread such that, so I will say that this is 150 pound per cubic foot. You remember this 1 foot, I took 1 foot length. So what is happening? Inches will cancel with inch. Inch will cancel inch. This is cubic feet. And this is per foot, and foot. So if you cancel, this will give you how many pounds? But since I took 1 foot, so this is pounds per linear foot. So if you do that, you will get W, which is 150. This is 8 enter, 12 divided. You have to take care of units. If you didn't take care of units, we are going to be in big trouble. Okay? Units are very, very important. So it is 8 enter and divided by 12 and 14 times and 12 divided times and 150 times. Okay? So let me do it one more time. Normally I do my calculation twice. Just if I did a mistake or something like that. So it is 116.67 pounds per linear foot, if my math is correct. Okay. This is W, which is required. L is given 40 feet. So I will say this is 5 times 116.67 pounds per linear foot times L to the fourth. Be careful. It is 40 feet and this to the fourth power. When you do this, it will give you feet to the fourth power or foot to the fourth power. But I have a foot here. So it will cancel. This will end it with the cubic feet. I need to convert the cubic feet into inches. So we multiply it by 1728. This is inch cubed per cubic feet. So this is feet. And this is feet to the fourth. And this feet to cube. So they will cancel. Divided by 384. This is another constant of the integration. E and I. EI as a product, we call it deflection rigidity. But the E for concrete is not given. E concrete is not given. Do you remember E steel? I told you any engineer or any civil engineer should remember the modulus of elasticity for steel, which I said to you, E steel is 29 million psi, or the 200 GPa, gigapascal. For E concrete is not constant, by the way. E concrete is about between 2 to about 5 million psi. A range. Because the concrete's modulus of elasticity E is a function of F sub C prime. And there is one equation you will find in my book or my books. It is given like this. It is 33 W 1.5 square root of F sub C prime. This is ACI empirical formula. ACI, American Concrete Institute. They came up with this equation, and we are using this equation. Or for normal weight concrete, we are using this number here is 57,000 square root of F sub C prime. W is the unit weight of concrete, which is 145 to 150. So here, if I plug this, so it is 57,000, and he gave me this the F sub C prime. He gave me the 28-day compressive strength is 4,000. I plug it into here, 4,000. And this is an empirical formula, by the way, empirical formula. Empirical formula by ACI. They did a lot of testing and they developed this equation for us. So units doesn't work here because in fact this is pound per cubic foot and this is in PSI. So when you take this is PSI, take the square root, what will give you? It will give you not something very strange, but this is the way the equation they developed for us. So empirical formulas do not follow the rules of units or balancing units. So if I take the 4,000 and take square root and you multiply it by 57,000, what number we are going to get? We'll get about 3.6 million PSI. And review my math, please, and correct me if I'm wrong, which is between the range, as I told you, because the modulus of elasticity of concrete is a function of the unit weight and the F sub C prime. But for normal weight concrete, they came up with this, which is they are using W about 147 or something like that. If you put this W here, 147, you'll get very close to this number. Or 150, something like that, and they round it. So in this case, I got another piece of information. So the modulus of elasticity E is 3.6 million PSI. PSI. And the last item is I. I, here it is, this is a rectangular beam, B and H, so it is BH cubed over 12. So I say that it is 814 cubed divided by 12. If you do this calculation, let's do it together. So when you receive my notes from the calculation here, let us see what number you are going to get. And review it, and if you find a typo or a mistake or an error, please let me know, and I will be glad to correct it next time when we meet. Let's do it very quick to see how we're going to get, if we're going to get one of these answers or not. And the deflection must be in inches. And I convert everything in inches and in pounds and so on. So it is 5, enter, 116.67 times, and 40, enter, and 4 to the times, and 1728 times, and 384 divided, and the 3.6 divided, and 10 to the power 6. Probably you are faster than me. That's good. You are, because you are younger than me. You're supposed to be faster. This is a new generation. So 12 times 8 divided, and 14 enter 3xy and divide. I got 1.02 inches. This is what I got if my math is correct. Delta max. Please go over it if you agree with me. This is the answer D. I hope you got the same answer. But units are very important. Except here, this to the fourth, you will find this. Do you know what 1728 came from? 1728 is 12 cubed. 12 times 12 times 12 is 1728. And by practice, you remember these things. Because 12 inches in 1 foot. If you cubed it, so 12 times 12 times will give you 1728. So let me put it that way, at least you can remember this. Here it is. So we need to be aware of that. And as you can see here, this beam, it will deflect as shown. It will concave down like this. When we build the bridges, assuming this is a bridge, assume this is a single span bridge, and this is a cross section, for example, for the girders supporting the slab. Do you need your bridge to be like this, to concave down like this? It will sag down for sure based on the maximum calculation we just got, maximum deflection to be 1.2. But in reality, we don't do that, okay? Because we have an issue. If we build the bridge like this, I will be in big trouble. And the people say, who designed this bridge? Oh, this is Mr. Mansour. Who is Mr. Mansour? Okay, Dr. Mansour, you did serious mistake by designing the bridge like this. I'm sorry, let me redesign it. So if you look to the bridge, if you build the girders to be perfectly straight like this, under its own weight. Remember, this problem is under its own weight. We did not put trucks on it. We didn't put any load in it. We said that the beam or this girder or this bridge will sag like this under its own weight. Let me just exaggerate it. The 1.2 inches at the center, by the way, the maximum deflection will be at the center. Should mention that. Probably I draw it. Yes, the maximum deflection, delta max, it is at the center, at center line, in the middle of the, so it will be like this. This is center line delta max. If you design, the bridge is still safe, by the way. If you design it and you allow this deflection to happen, the bridge is still safe. But we do have two issues if you build the bridge like that. Number one, psychologically, the users of the bridge, when they see the bridge has been sagged down like this, and they say, oh my God, Daddy, don't go over this bridge. This bridge will collapse. It's still safe. No, it will not go down. Okay? Psychologically, okay, the people will be really scared to cross a bridge that sagging down like this. This is one problem. The other problem is, it was raining yesterday, my friend, and we have some nice storm or big storm, and the water is here. The water is here. So the water is additional load. So in addition to the weight of the bridge itself or the girder itself, which is a dead load, we have additional water. So the bridge will even go down. Oh my God. And you can calculate how much water will accumulate based on the storm, the average rainstorm. Do you remember the Q is equal CIA? Do you remember the CIA formula? We'll talk about this. This is I, the intensity. This is the rainfall intensity. Rainfall intensity. How many inches per year? We can calculate how much water will accumulate here. And I will add this load and calculate the deflection. But my friend, psychologically, nobody is willing to cross this bridge. You are causing additional deflection due to the accumulation of the water. And if somebody goes, and the third problem is, somebody goes over this bridge, here is Mr. Mansour, has Lexus 2021 or 2022, and go over this, he will swim here. Hydroplanning. And this is a serious issue. And this is why when we build the bridges, and you notice that we build the bridge under its own weight to be like this. We build it, it has a camber, and there is something is called Camber Diagram, and I'm sure that some of you did it, okay? We build the bridge to be concave in the opposite direction. I'm just exaggerating. We build it to be like this, okay? After we remove all the force work, the bridge will go down a little bit. It will deflect because everything, deformable bodies, it will deflect down. But it still has some camber built in. It's called Camber diagram, and we do have we need to draw the Camber diagram, and in construction the contractor has to form form it or shape the forms for the Camber diagram. I don't know how many of you prepare the Camber diagram. Okay, it's called Camber diagram. Which we calculate the deflection at each foot, and we form such that when the bridge under its own weight, which is the deflection, it still have some camber. This is number one. If it is raining yesterday or today, here the water will be drained, number one, and we collect the water somewhere and we take the drainage system, and some of you did that. So this is the first benefit I will get. The water will not stand. When Mr. Mansour is driving, okay, his Lexus, no water on the bridge, so no hydroplaning. And above all, appealing to the eye. Nobody will say, oh, or my kids will say, Daddy, don't go over this bridge. This bridge is going to collapse. You see, it's sagging down like this. The engineer who designed this, Daddy, you designed it? Yes. Oh, I'm sorry. So we don't do that. Okay. So deflection calculations are very, very important. So we need to understand the deflection calculation from two perspectives, as I mentioned. Number one, we need to understand it from the concept. What are the parameters that will influence the deflection? The definition, we should know what the deflection is, number one. Number two, what are the parameters that will affect the deflection calculations? Because they might be asking you this question, and it did happen before. Okay, over these 30 years, I heard all stories. Not all stories, most of the stories. Let me put it that way. I don't like to say all, because my lawyer always advised me don't use all. They say frequently, or most probably, or most likely. Okay, so I'm trying to use the terms that. So I heard many stories. Okay, and also we need to know how to do the calculations. Like the problem, we solve it together. That the one you are going to review it and tell me if the 1.02 inches is the correct number or not. Okay. I hope that all of you are following all this, and when you receive the notes, obviously it will make more sense to you. And as I said, that you are very welcome to review it and let me know if there is any disagreement. We can resolve all our disagreements without going into the court, because I hate to go to court. Okay. So if you find something wrong with my calculations, don't take me to court. I will correct myself. Okay. This, for example, problem number 36. A conceptual question, the deflection or the deflected shape, 4 deflection shapes for an overhang beam. This beam is called overhang. We need to know all the types of beams also. I talked about the cantilever beam, this cantilever beam, and the simply supported beam, the one it was in problem number 16. This is called a simply supported beam, single span. Okay, and this is called overhang beam. Why overhang? Because this is the beam, how it looks like. So overhang from one end, and there is a concentrated load here. So he's asking what the deflection diagram looks like, or these deflection diagrams are shown as dotted lines. So which one is representing the deflected shape of the beam, or we call it the elastic curve, by the way. In school, if you remember, we call it elastic curve. And we have an equation for the elastic curve. Do you remember this equation? Which is 1 over rho is equal m over EI is equal to d2y by dx squared divided by 1 plus dy by dx squared, and this is 2/3. We start with this equation when integrate twice and constant of integration and all these things. Nobody will ask you to do this. This is in school, we did that. This is mechanics of materials. But we should know the general shape of the elastic curve or the deflected shape of the beam. And the elastic curve will help me to do two things. The first one, the deflection. I would like to know how much is the deflection, the magnitude and the direction of the deflection. And the other thing is the steel, where the steel should go. And I will talk about this immediately after this. But let's just finish this. So, do you think this is the deflected shape of the beam? No. Do you think this is the deflected shape of the beam? No. Do you think that this is the deflected shape of the beam? No. So, if you push this down, so the beam will deflect as shown. It will deflect as shown. So, this is the closest one or the perfect answer or the best. Always you're looking for the best answer, not the perfect answer, best answer. Even if the shape is not perfectly as it's supposed to be, non-linear and all these things, but still this is the best. So as you push down, you will find that the beam will come down, and this is the tension side and this is the compression side. This is the tension side and this is the compression side. So if this is he can give you the same beam and they will tell you, look, this beam is made of concrete and we have 4 cross sections as shown. The same question, but instead of giving you 4 deflected shapes, it will tell you that an overhang beam ABC carrying a concentrated load of 2 kips at the free end at C. And he gave you the spans. Okay, this span here is 14 feet and this span here is 12 feet. The cross section or 4 cross sections are shown. Which one is the correct cross section where the reinforcement should be placed? And he will give you cross section A, cross section B, cross section C, and cross section D. And he will tell you, okay, cross section A is like this, cross section B is like this, the cross section C is like this, and the cross section D is like this. And we can put even the stirrups, the shear reinforcement, but he's talking about the main reinforcement. Normally they show the main reinforcement, but I'm showing also the shear, but it's not important for you to, just in case, if you give the shear reinforcement, does not affect my answer at all, but he's looking for the main reinforcement, these 3 bars here. Okay, so the one at the bottom here, one in the middle here, one the top here, one. So which one is the best answer? A or B or C or D? The same question, but he will not give you the 4 deflected shape. But if I understand the concept, because the deflected shape or the elastic curve is telling me where is the tension and where is the compression. So let us vote. We are a democratic country. As I said that we are going to vote next November. So A or B or C for this, where the rebar should be placed, where the main reinforcement or the flexure steel. The flexure steel should be placed. Either A or B or C or D. Let us vote. So let us count, okay, and give me your answer, please. And I'm not calling names. Okay. Any other answers? Okay. Okay, thank you very much. Okay, I think all of you got it right for those who answered, but we need to vote because the voting is legal in this country, is legal. Everybody has the right to vote. So next time I'm expecting that all of you will vote. Okay, so I encourage you to. So the answer C, why? Because this is along the tension side. And we know the stress strain curve for concrete is like this. If you remember the stress strain curve for concrete, it is like this. And we need to also remember, as we draw the stress strain curve for steel, we need to remember the stress strain curve for concrete, for soils, for wood, and so on. Okay, and I can talk about all these. So stress strain curve is a relationship between strain and stress from its name. So this is epsilon, which is delta L over L, and this is sigma, which is B over A, but we call it F sub C prime. So F sub C prime is sigma. The curve for stress strain curve for concrete is this came from the cylinder, by the way, from the 6 by 12 cylinder, the one I showed to you, 6 inches by 12 inch. And after we apply the load and we collect the data, there is something called compressometer. We put something around this cylinder. It has a mechanical extensometer to measure deformation. So it will be like this. It has a little bit of linear, and after that it will go non-linear until we hit the maximum, and after that, so it does have a little bit of linearity at the beginning, not like steel, a little bit of linearity at the beginning, and after that it goes non-linear, it goes all the way up to here, 12 feet. And this is the F sub C prime, which is the maximum compressive strength. And this strain, by the way, this strain here is about 0.002. Because if you go to the steel manual, the concrete manual, they allow to go to 0.003. The maximum compressive strain 0.003. This is the maximum permitted by the code, by ACI code. The European, they are using 0.0035. They go a little bit beyond that. But this is about, let me put it that way, but this is exact. So it is, this is under compression. But concrete is very weak in tension. In fact, if you did a tension test, which there's no standard tension test. There is no ASTM. This is ASTM. This is the American Society for Testing and Material. In fact, ASTM C39, by the way. C for cementitious, and the number of the test is called 39. Because I did this for about 40 semesters or maybe 50 semesters. I taught the materials. I have manuals for the students back in Las Cruces and CSU Fresno here. So if you did the tension test, you will find the tension test. Here it is. This is the stress strain curve under tension. Very small, is about 10% only of F sub C prime, 10 to 12 or sometimes 15% at the most. But design, we ignore the 10%. Code does not allow us to consider the 10% of the tensile capability of concrete. They are telling ignore it, assuming that the steel will carry the entire tension and the concrete will carry compression. So going back to this, you will find that, yes, I need to put the rebars along. This is the best. Here he put one bar along the tension and one bar along the compression. This is not the maximum benefit of the rebars. This is the maximum. This is why the answer C is the best answer. Sometimes we use compression steel, where we put steel along the tension and compression, but this is for the long-term deflection and the creep. Something's called the creep. Do you remember the term creep? Creep, which is the deformation under constant load over time. But nobody will ask you about that. Except I covered a little bit also in material section about the creep of materials, not the creep of concrete. Creep of concrete is not required for you to know it because it's something that beyond the NCAAS exam. Okay, so the other problems that that the other exams, the fall 2019, it is about 40. How many problems? About 47. Oh my God! So sometimes when I give them the exam, so mass diagrams are very, very important. I cover this a lot. obviously project management, trusses, hydraulics, geotechnical, soil classification. Soil classification is extremely important, and I can spend, this is fall 2019 exam. If you look to this problem here, problem number 19 and 20, there are two systems for soil classification. As all of you know, soil classification is for the AM and for the PM, by the way, and PM also for the geotechnical, for the construction, and for transportation. Expect the soil classification to be in all these. The AM, you can find the soil classification. In the PM, okay, you can find it in construction for sure. You can find it transportation, and you can find it in the geotechnical. I don't know structure, if I'm not, I can remember really if structure can include this or not, but because I taught structure a couple times, and water resources, I didn't teach the water resources because I don't have books ready, but I taught these things. Structures also I taught it, but the books are not ready. My books are here, construction, transportation. These books, one day it will happen, I don't know when, but because for the last 15, 20 years, I'm using my own books because I decided to do that. Even it's too much stuff, too much headache for me, but I prefer to. So soil classification. Soil classification, there are two systems. The AASHTO system, or the A system, and the US Unified Soil Classification System. So soil classification, the two systems that we need to know, it is Unified Soil Classification, Unified Soil US Classification System, and the AASHTO system. AASHTO, the American Association of State Highway and Transportation Officials, and the Unified Soil Classification System. It's very common question, as I told you, the USCS, yes, USCS, Unified Soil Classification System. Unified Soil Classification System. This, they call it the A system because it does have A1 to A8. This is called the A system. And this is why you'll find that, for example, problem number 20, it does have the A number starting with the A, letter A. A1, A2, A3, A4, and so on. Until A8. And AASHTO, they started this, by the way, in 1929, because AASHTO started with the roadway design. The Unified Soil Classification System, they are using letters. They are using 4 letters first. They are using S. Let me use different color. They are using, let me use the same. They are using G for a gravel, and S for sand, and C for a clay, and M for silt. Because S, they used it once. So you will find under the Unified Soil Classification System, you will find that the table that we are using, that it does have, let me show you the table, starting with these letters, except the organic. So this is what they are looking for. G for a gravel, and after that S for sand, and C and M, obviously the organic is just for the O. So if you'd like to add the letter O, I have no problem with that, O for organic. Okay. So those are the first letters will show up. G for gravel, S for sand, C for clay, M for silt, and O for organic. And there is another letter added to it. If it is a single syllable, okay, because we have single and double, by the way. Single, symbol, like this. This is the group symbol, okay, this is a table of the USCS. They are using W for well graded, B for poorly graded, and so on. We can talk about this later on. And they break the table into two main, they make it three. The blue one, and this one here, and this one here. The top portion is for the coarse grained soil. This is for a gravel and for sand. So because soil in general could be classified as it's page number 5. So soils in general could be classified as coarse grained soil, and those are the G and the S. G for a gravel and the S for sand. This is what we call it coarse aggregate, if you remember when I talked about concrete, and this is what they call it fine aggregate. For the fine grained soil, we have the silt and the clay. C for clay and M for silt. And you'll find that the difference between, or the barrier between the fine grade and coarse grain is the number 200 SIF. Anything past number 200 is fine grained. Anything retained number 200 is coarse. In fact, if you go further, you will find there is a number 4 here. Number 4, anything retained here is coarse, which is a gravel. Anything go through number 4 is sand, but should stay here in number 200. So the sand is between number 4 and number 200, and the silt and the clay, both of them, they pass number 200. And this, when we say it's SIF number 4 or SIF number, this is a SIF number 4, means that it has 4 openings per linear inch, not per square inch, by the way. So 1, 2, 3, 4. This is 1 inch. This is what is meant. 4 openings per linear inch. So the soil classification that you might see on the exam is important as far as the concept. But let me ask you, for the two systems that you are asked to know, the AASHTO system, the A system, the American Association of State Highway and Transportation Officials, great organization AASHTO. They have tons of books, tons, design books and testing books, and the green book, and some of you or most of you are familiar with the green book. Why do you call it green? Because it's green. Okay, This is the green book, which is a 2018. Let me see if I have, here it is. Geometric design, here it is. 2018, this is the one we're using for the transportation, geometric design of highways and streets. They call it the green book because it's a green, okay? And most of their books are green except one book. Okay, it came in 2010. It's called the yellow book or the yellow manual, which is the highway safety manual. I say this is the first time ever they came up with a yellow manual, to the best of my knowledge. So they call it the yellow manual because it's the yellow. We use it also for the transportation group. So let me ask you a question, and I believe this question is somewhere, if I remember correctly. If I find it, that's good. If not, I will phrase the question and you can tell me. Oh yeah, here it is. In the AASHTO book, no, my God, not AASHTO book, the NCEES book. These two systems, question number, this is the AM. Question number 130. If you don't have the book with you, here it is. It said that the most essential criteria for a proper soil classification using the unified soil system, unified soil classification system, or the AASHTO soil classification system are, in order to use the unified system or the AASHTO, we need some properties: water content and soil density, Atterberg limits and specific gravity, a grain size distribution and water content, a grain size distribution and Atterberg limits. 4 possible answers, 3 are wrong and 1 is correct. So what are the requirements? Before we go into depth and talk about how to classify the soil based on whatever system you are asked, but I should know what are the requirements, because if I don't know what are the requirements, I don't know what to use. So water content, by the way, we use the letter W, which is a moisture content. Soil density, we are using gamma, and gamma, by the way, it has gamma dry and gamma wet and gamma prime and gamma saturated. We have more than one gamma for soil density, by the way, and we can talk about this later on. Atterberg limits. Professor Atterberg, he came up with limits, which is liquid limit and the plastic limit. And the PI, which is a plasticity index, is the difference between them. A specific gravity. What's specific? We are using GS, or sometimes we call it SG. C, a grain size distribution. A grain size distribution is obtained from 2 methods: either sieve analysis or the hydrometer. Yeah, I spelled it correctly. Sometimes I check the spelling. Sieve analysis or the hydrometer. Sieve analysis, we use it for the coarse grained soil. Coarse grained soil, grained, which the gravel and the sand. The hydrometer, we use it for the fine grained soils, which is, we just talked, which are the silt and the sand. The fine grain, this is silt plus sand. Here we're talking about the gravel plus sand. Oops, so silt and clay. Oh my God, don't do that. Silt and clay. This is sand to ice. No, sand, gravel and sand. And the water content is repeated again, which is lowercase w, normally expressed as a percentage by the. And the answer D, a grain size distribution and the Atterberg limits, which is the liquid limit and the plastic limit. Liquid limit and PL is a plastic limit. So he gave us a combination of parameters. So we have one answer is the best answer or the correct answer, and the other answers are not the correct ones or the wrong one. Excuse me. You will find that the answer D is the correct one. We need a grain size distribution and the Atterberg limits. You need to get these two pieces in order to, and this is why you will find that the problem that I will discuss it probably next time when we meet, but you are very welcome to work it in your own. This problem here, and there are many problems like this available in the market or in textbooks or geotechnical books, the one I used to teach geotechnical a lot. So here it is, the grain diameter, this is a grain distribution, the percentage here, and he gave you the liquid limit and the plastic limit. So the LL is given and the PL is given. In order to determine the soil classification based on the unified system and the soil classification based on the AASHTO, the American Association, which is the A system. We need to know that, and I will be glad to discuss these things, okay, next time when we meet, because I have to go, and right now, after a few minutes, I have to be in another place. So I hope that you enjoyed the class today. I will add the session that I missed before. So we still have 2 additional sessions. Let me go to where is the website very quick, or go to or go to the free here. I think if you go to the free, I think my staff, they put, here it is. Yeah. So these are the free classes. So today is the 5:30 first, because I moved it from yesterday. So I still have 6. Let me just make this a little bit bigger if I can. Here we go. Okay. So we still have, oh, I make it too big. That's good. Okay. Okay. So we still have June the 6th and June the 20th. I believe these times are correct. As I told you, it's only one ID. So if there is anything wrong, you will find that the ID will give you, okay, and you can sign up very easily without even sign up, and you can get it. I will add the B exam in October. Check with the NCAAS California. Probably we need to change this because they just announced, okay, recently that the exam is not going to be, because this was prepared way back based on before they decided that the exam would be given on October 20. That's why I say check with, just in case for any changes, because legally I don't like to be liable for any so the board is the best source for all the information, and this is what my lawyer, when he checked my website, he told me that you have to put this statement, because to be fair and honest with everybody, check with the board. The board has the final say about the exams. I have nothing to do with the exams. I'm here to try to help you to prepare for the exam, and I wish you the best, and I will do my best to help you all the way to the end. And I will add one more session, because if I remember correctly, I missed one session here, so I will add it. So thank you very much for coming. Stay healthy and pray for me to stay healthy, because if I stay healthy, I will keep doing this, and we'll continue our discussion. I will scan these things and send it to you immediately, or probably after I go, because I have to go and pick somebody right now. There is a demonstration here in Fresno today, and some of my family members, they said to go to demonstration. They asked me, you should cancel the class and go to the demonstration. at the city hall. I said, no, I will go to the class because I moved it from yesterday to today, so I don't like to, okay, to move it further. So I need to go and pick somebody right now, and from the demonstration place, hopefully that everybody's still safe and nobody is get hurt. So do your best, and I will do my best. And again, thank you very much for coming, and I wish the best to all of you. And the most important thing is to stay healthy, please, because health is number one. Thank you very much. Get in touch with me if you have any question. I will do my best. I am extremely busy, but I will do all my best to come back to you as soon as I can. Don't never give up. If I didn't come back to you immediately, send another email. Okay, don't say that. Okay, I never ignore anybody intentionally, but because of my workload and my responsibilities, sometimes I am behind, and I wish you the best. Thank you very much. Bye-bye. And this lecture, as I said, that is recorded, and somebody will take it and load it on the system. It will be under the same location I showed you before. Thank you very much, and enjoy the rest of your day, and good night, everybody. Bye-bye.